Hello, today we're doing 6.2 part 2. We're applying properties of radicals. So yesterday we did properties of rational exponents. Today we're doing properties of radicals. So basically it's the same properties you know when we just have a regular square root. If we have the same root, we can multiply the insides. If we have the same root, we can divide the insides. If we have like radicals, you can add or subtract as long as they're like terms. And we'll see a little bit of all that. We're going to do more adding, subtracting, multiplying, and dividing tomorrow. Today we're mostly going to be simplifying. But okay, here's what I like to do. I like to make my factor trees until I get pretty good at it, and then eventually I won't. This is a cubed root. So this time I'm looking for things that repeat 3 times. So think of what multiplies to give me 54. First thing that comes to my mind is 6 and 9. 6 can be broken up into 2 and 3. 9 can be broken up into 3 and 3. Now because it's a cubed root, like I said, I'm looking for something to repeat 3 times. I see 1, 2, 3 threes. I write it on the outside. I have a leftover 2 on the inside. And make sure you write the index radical right there. There you go. Okay, let's go ahead and try 80. Now 80, I'm looking for things to repeat 4 times. So 80, I think of 8 times 10. 10, I think of 2 times 5. 8 is 4 times 2, and 4 is 2 times 2. Now again, we have the 4th root. We're looking for something to repeat 4 times. I see 4 2s. 1, 2, 3, 4, and on the inside is a 5. Okay? All right, let's do this again. More practice. Now down here, I have the cubed root of 8 times the cubed root of 8. I would go ahead and multiply those. It doesn't matter. I mean, you can just start making a factor tree, but I'm going to have the cubed root of 64. Now, I know that if what number to the 3rd power gives me 64, I don't need to make a factor tree. I know that my answer is 4. Now, you can make a factor tree, and then what will end up happening is you will have nothing that falls on the inside. You will have no leftovers. I'll show you really quick, just so you know if it's a perfect cube. You should recognize it though because I had you memorize that index card. Okay, so here's what ends up happening. It's to the 3rd power, so I make my root. I see 1, 2, 3 2s. I see 1, 2, 3 2s. I multiply these 2 on the outside and I have nothing on the inside, so I don't need to write the radical. So either way you do it, you are going to get 4. Okay, now this next one is a pretty big problem. So I don't think I would bother multiplying these together. I would just start making my factor tree. I know that when I have like radicals, I can multiply the inside. So what I would end up doing is just doing 80. I know 80 is 8 times 10. I know 8 is 4 times 2. 4 is 2 times 2. And 10 is 2 times 5. 128, I just started very simply with 2 times 64. 64 is 8 and 8, and 8 is 4 and 2. This 8 is 4 and 2. Big factor tree, right? That's why when you get good at it, you can just think of what perfect 5th root divides into the giant number. Okay, so remember, I'm looking for something to repeat 5 times. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And on the inside, don't forget about your 5. We multiply, so I get 4 to the 5th root of 5. So that's a pretty big factor tree, but you can do it, right? And like I said, when we get good at this, we'll practice. We'll say, what's a perfect 5th root that would divide into 80? Is there a perfect 5th root that would divide into 128? Or you can multiply those numbers together, get a really big number, and play around on your calculator and figure out what perfect 5th root would divide in. Okay, now rationalizing the oh no, this one's not rationalizing. We will do rationalizing tomorrow. Okay, we're doing division. You can divide 3 into 75. So when you do that, you get the square root of 25. It's on the bottom, and the square root of 25 is 5. Pretty easy, right? These are like roots. You can divide 5 into 80. So when you do that, you get 16. You can take the 4th root of 16. What number raised to the 4th power gives me 16? And the answer is 2. Okay, I believe I have some U-tries for you. Yep, one factor tree, big factor tree, and then one multiplication and then a factor tree. Go ahead, try those on your own. If you have any questions, comments, or concerns, write them on the bottom of the paper, and I'll see you tomorrow in class.